Hi everybody, welcome to Meet Your Watershed. I'm Kathy Grant, City of Lodi Watershed Program Coordinator, and today we got something a little bit different. I got my friend with me, Stephen Clark, and his buddies.
They're bugs. We are going to be testing samples from the atmospheric river that occurred recently and how it affects the community of organisms that live in the streams around here. Specifically, we're testing female bugs as a toxicity test, just like we do in a professional laboratory.
Toxicity, that's the word of the day. So we're going to head into the classroom.
Yes.
But help me understand before we get in there what you are doing with your bugs.
Yeah, so today what we want to do is teach the kids how to do a toxicity test.
So it's the runoff from the streets of Lodi that's not treated, that's running into our local waterways. We're answering the question, how does that runoff impact the river, correct?
Sure, yeah, that's what we're doing is we want to determine with the samples that are collected, is that healthy for aquatic organisms to live in? And we're using this representative organism as an indicator. Now, what can be in that water is a variety of things. As humans, we use things to control pests around our property, and that's of concern because if we don't apply those well and it runs off the property, it can go down the storm drain and into our creeks and into our rivers and have a negative effect. There's a whole variety of other things. You'll see oil as droplets underneath of cars, brake dust, and a whole variety of things we use just naturally every day in our world that can have an impact on the environment.
So this is a kill test.
This is a kill test. It's what we used to back in the day in aquatic toxicology called kill 'em and count 'em.
Kill 'em and count 'em.
But what we're doing is we're looking at survival only. But we also wanted to build in really good scientific principles into this testing.
I understand that outdoor water runoff from streets goes to the river, it's not treated, but I also know you treat City of Lodi effluent coming through the wastewater plant, which is our toilet water that's been treated. What's in that wastewater that could be a problem? Besides our waste that's removed, so how does this work?
The wastewater treatment plant is really cool in how it works. It has an invertebrate population that treats the sewage. The problem is when other things get in there that aren't supposed to be in there. And so we talked about the prospect of pesticides getting into surface water bodies and creeks and streams from being applied outside. If people don't dispose of that properly and pour them down the drain in their toilet or get washed off from their hands at high enough concentrations, that then can have an impact on the invertebrate population that's supposed to treat wastewater, and then what goes to the wastewater plant is not what it should be, and therefore having a negative impact.
Amazing, you don't think of a toilet as part of an ecosystem. Or flush the toilet, it's...
Yeah, you think it's flushed and gone.
The flush and gone. No, it's going to another place.
It is going to another place. And it's good that we're doing environmental assessments to determine impacts on the environment, and what we always hope is the outcome is positive. But if there is a negative outcome, then what we should be doing is investigating why and trying to resolve it. And that's one of the things we're teaching the kids here today, is this is an investigative tool with these organisms to check in on the environment.
Well, I'm really glad you're here. It's been a busy time of year for you, I know, but you took time for the students. So let's head in and get to work.
Let's go check it out.
Let's do it.
Alrighty, how's everybody doing today? How many of you like lab work where you get to do things with your hands? Right. An introduction to aquatic toxicology. First, we have to have samples. And so the Lodi team has collected 4 different samples for us to test. Second, we need to have an organism culture, and we need to have control waters that we're going to be able to put them in to complement testing with the samples. The next thing we need to do is we have to label things. We have to label all of our cups so we don't get them mixed up. We're going to label data sheets to pair them up with the samples that will be tested. We're going to add food because just like us, the aquatic organisms we're testing, the species we're using is Daphnia magna, has to have food. It requires algae and another food as a zooplankton to eat during the test period of time. The next thing we do is we have to add the organisms into the test chambers, and then we make sure that we got the right count. Hopefully, we put the right quantity of organisms in each test chamber, and then on day one day later, the students are going to do counts of organisms, and we'll be able to begin to understand if there's any toxicity or not by organisms that have died. And then finally, on day 2, we're going to get final counts, and then we're actually going to interpret the data. We're going to first look at the control, and then we're going to look at the different samples. Okay, so can everybody see the bar plots up here? All right, what was the survival in the control at 24 hours? And what was the survival at 48 hours?
So Stephen,
Yes.
tell me what you learned. Well, summarize it.
Well, I think first and foremost is the students were phenomenal and got an acceptable toxicity test, which means the control met the test acceptability criteria. So even with things in a classroom like temperature that's being turned off overnight and all the things we'd have regulatory control over in our lab, they got an acceptable test. They tested 4 samples. The wastewater treatment plant sample came back great, no different from the control. One of the surface water samples showed a 20% reduction in survival compared to the control. And that, in our laboratory, through all of our training and accreditations and all that, would actually be considered toxic. Whether or not it was or isn't in a environmental monitoring study from a school, you know, we'd have to kind of couch that a bit with the experience of the students.
So you go back and retest and retest.
We go back, retest, and evaluate it further. And just really, overall, really pleased with the outcome, because just getting an acceptable control, you know, is a big deal. And the students aging from, what, 5th grade through high school were able to do that.
Yeah, it was all hands-on.
Yeah.
It was nice to see math and science doing their thing.
And that was part of it at the end. What we did is we took the data and we worked it up just like a laboratory would with percent effects and plotted the data as well.
Yeah, well, thank you for doing it.
Yeah, well, it was fun.
Appreciate it. So thank you everybody for hanging out with us for a couple days here and learning all about water toxicity. And now it's time for you to do your part. Please keep your waterways clean inside your home and outside your home. All water's connected, and we are the stewards of those waters. So we appreciate that you've listened, you've come this far, and now it's time for you to do your part. See you around the watershed.